Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss 5 data structures that are fundamental for programming. So if you are ready, let's start today's video. Five data structures that are essential for programming and enabling efficient data storage and manipulation. Data structures play a crucial role in computer programming as they enable efficient storage and manipulation of data. By understanding and utilizing the right data structures, programmers can optimize their code and improve the overall performance of their applications. Here are 5 fundamental data structures that every programmer should be familiar with. 1. Arrays. An array is a fundamental data structure in computer science used to store and organize a collection of elements of the same data type. Each element in an array is identified by its index or position within the array, and you can access or modify elements by referring to their respective index. Arrays are widely used because of their simplicity, efficiency in element access, and their predictable time complexity for various operations. Key characteristics of arrays. Homogeneous data. Arrays store elements of the same data type, for example, integers, floating point numbers, characters. This makes them suitable for situations where you need to manage a collection of similar items. Fixed size. In many programming languages, arrays have a fixed size when they are created. This means that once you declare an array with a certain size, you cannot easily change the number of elements it can hold. If you need dynamic sizing, you may use other data structures like lists or dynamic arrays. Contiguous memory. Elements in an array are stored in contiguous memory locations. This property makes it efficient to access elements by their index since you can calculate the memory address of an element using simple arithmetic. Arrays are a fundamental building block for many other data structures and algorithms. They are used in a wide range of applications, from simple list storage to more complex data structures like stacks, queues, and matrices. However, due to their fixed size and potential inefficiency for insertions and deletions, you may opt for dynamic arrays, linked lists, or other data structures in situations where the size of the data collection varies frequently. 2. Linked lists. A linked list is a fundamental data structure in computer science used for organizing and managing collections of data. It consists of a sequence of elements, each of which contains a value and a reference, or link, to the next element in the sequence. Linked lists are particularly useful when you need dynamic data structures that can efficiently insert and delete elements at various positions. There are several common types of linked lists, including a singly linked list. In a singly linked list, each element or node contains the data and a reference to the next node. The last node typically points to null to signify the end of the list. Singly linked lists are efficient for forward traversal. B. Doubly linked list. In a doubly linked list, each node contains 2 references, one to the next node and one to the previous node. This bidirectional structure allows for efficient traversal in both forward and backward directions. C. Circular linked list. In a circular linked list, the last node's reference points back to the first node, creating a loop. This can be useful in applications where you need to cycle through the list continuously. Linked lists are used in various applications, such as implementing stacks, queues, symbol tables, and more. They have some advantages and disadvantages. Advantages. Efficient for insertion and deletion of elements at any position, provided you have a reference to the element. Dynamic in size, so they can grow or shrink as needed. Memory allocation is flexible, as nodes can be scattered in memory. Disadvantages. Accessing elements by index is not as efficient as in arrays because you have to traverse the list. Extra memory is required for storing the references, making them less memory efficient than arrays in some cases. Linked lists are a fundamental concept in data structures and are used as building blocks for more complex data structures and algorithms. 3. Stacks. A stack is a fundamental data structure in computer science that follows the last-in first-out or LIFO principle. It can be thought of as a collection of elements, similar to a physical stack of items like plates or books. In a stack, elements are added and removed from the top of the stack, and the last item added is the first one to be removed. Key operations associated with a stack are: A. Push. This operation adds an element to the top of the stack. It's analogous to placing an item on top of a physical stack. The new element becomes the top of the stack. B. Pop. This operation removes the element at the top of the stack. After the pop operation, the element previously below the top element becomes the new top. C. Peek or top. This operation retrieves the element at the top of the stack without removing it. It allows you to examine the top element without modifying the stack. Stacks can be implemented using various data structures, such as arrays or linked lists. The choice of implementation depends on the specific requirements and constraints of the application. When using an array, it's important to watch out for stack overflow means when the stack is full, and stack underflow means when you attempt to pop an empty stack to ensure the program stability. 4. Queues. A queue is a common data structure in computer science and programming that follows the first-in first-out or LIFO principle. In a queue, elements are stored and retrieved in a linear order, with the element that has been in the queue the longest, the front or head of the queue, being the first to be removed. New elements are added to the rear or tail of the queue. Queues are used to manage data and perform operations such as insertion, removal, and traversal in a systematic and orderly manner. Key operations associated with a queue data structure include: A. Enqueue or add insert. This operation adds an element to the rear of the queue. It is often called enqueue or push. B. Dequeue or remove retrieve. This operation removes and returns the element at the front of the queue. It is often called dequeue or pop. C. Peek or front. This operation allows you to view the element at the front of the queue without removing it. It can be used to inspect the next element that will be dequeued. D. Is empty. A function that checks if the queue is empty. If the queue is empty, it means there are no elements in it. Queues are used in various applications, such as task scheduling, breadth-first search algorithms, managing print jobs, and handling requests in computer systems. They are especially useful in scenarios where the order of processing or servicing elements is critical. Queues are fundamental in computer science and are used as building blocks for more complex data structures and algorithms. They provide an organized way to manage and process data in a manner that adheres to the FIFO principle. 5. Trees. A tree is a widely used data structure in computer science and is a fundamental concept in data organization and algorithms. Trees are hierarchical structures that consist of nodes connected by edges or branches. Each tree has a root node, which is the top-level node, and 0 or more child nodes. These child nodes, in turn, can have their children, creating a hierarchical structure. There are various types of trees used in computer science, including: A. Binary tree. A tree in which each node has at most 2 children, typically referred to as the left child and the right child. B. Binary search tree or BST. A binary tree in which the left child of a node contains values less than the node's value, and the right child contains values greater than the node's value. BSTs are commonly used for efficient searching and sorting. C. AVL tree, a self-balancing binary search tree in which the heights of the two child subtrees of any node differ by at most 1. D. B-tree, a tree data structure designed for efficient storage and retrieval of data in a database or file system. E. Tree, a tree-like structure used to store a dynamic set of strings, often used for text retrieval and autocomplete features. F. Red-black tree, a self-balancing binary search tree in which each node has an extra bit for denoting the color, red or black, ensuring the tree remains balanced. G. Heap, a specialized tree-based data structure that satisfies the heap property, commonly used for priority queues. Trees are versatile data structures with a wide range of applications in computer science, including hierarchical data representation, searching, sorting, and optimization algorithms. Understanding tree structures and their properties is essential for designing and implementing efficient algorithms and data storage systems. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.